Good morning, students. Welcome to the today's class. So, when is your exam? Just a second. Okay, students. Today we would like to discuss about lecture number 10. Okay. This is all belongs to binary codes or codes. Excuse me. So before going to that one, let us recapitulate what we have seen in the previous class. We have seen that two's complement, right? What we have seen that we have seen two's complement, right? And one's complement also we have seen complement representations that we have seen, right? So what in the sign magnitude representation, MSB bit is dedicated for sign representation, and the remaining bits are used for magnitude representation. Magnitude, the actual value is the except MSB, whatever the bits are there, those will be defined there. Okay, but two's complement representation is not like that. Yes, MSB is meant for saying that whether it is positive number or negative number, but if you want to find value, we have to take all the bits, right? So that's what we have seen. For example, 10101, if you am writing like this, sign magnitude representation, so this should not count. Okay, so but what we have to say, so we need to say that minus of this value is 5. We have to write this. Whereas in case of two's complement representation, yes, this is a negative number only, but we have to take the entire number. So one, we have to take the entire number, that is 10101. So entire number I have to consider for the value. So what is this value? Everybody know that this is a ones place, two place, 4, 8, 16. Okay, this is where minus 21. So in 2's complement presentation, it's minus 21. Fine. Now we would like to discuss about the arithmetics. Okay, so 2's complement arithmetics. Okay, no problem. 2's complement arithmetics. What does it mean? So subtraction that we want to perform. So in this complementation point of mathematics, in the sense, it is a subtraction. Subtraction, right? So let us take one example. So we will apply this kind of thing. For example, 10101. So yeah, it is fluctuating. Next one is 14011. 140. So these are the numbers that I'm taking. Okay, this is called, for example, x value. This is called y value. Okay, so I want to perform x minus y. What is the value? That is the one question. The second question is y minus x. What is its value? So I want to take these two. Okay, very simple. Whatever the nines complement that we have done, the same procedure that we have to do. Okay, so what is the x value that I have taken? So 1010100, right? So minus of what is the subtrahend? 10001. I'm extremely sorry here. So please bear with me because I'm out of station. So network is not good. Fine. So 1000011 is the number need to be implemented or represented in 2's complement form so that addition can be possible. So in order to do this one, what I have to do? So 1010100. What is the 2's complement of number? So now I have to consider the 2's complement of 1000011 is required so that I'm able to perform addition operation. Is it right? That's what we can do. So what is the 2's complement of this number? Now 2's complement of 1000011. What is the value? First, 1's complement is required, which is equal to 1's complement plus 1 is required. Okay, what is the 1's complement? 0, 1, 1, 1, 1, 0, 0. Plus 1 I need to add. So what is this value? 1, 1, 1, 1, 0, 1 will be the 2's complement. So it's 2's complement number. What is this value? 0, 1, 1, 1, 0, 1. So I have to substitute there. Okay. Therefore, what I can write now, 1, 0, 1, 0, 1, 0, 0, 0, 1, 1, 1, 1, 0, 1. So now we have to perform the addition. What is this addition? 1, 0, 0, 1. 1 plus 1, 0. 1 plus 1 plus 1, it becomes 1. This carries becomes 1. This value is equal to 0, it becomes 1. So 1 plus 1, 1. And sorry, 1 plus 1, that is 0. 1 plus 1, that is 0. And yeah, better I need to write this one as 0. And the carry will be the 1. Carry will be the 1. It's a very, very important one. Okay. Whenever we have a carry signal here, just we have to ignore this carry. What we have to do? We have to ignore this carry. Okay. So therefore, carry is ignored. Carry is ignored. So whatever the value we see here, that will be your answer. So hence, carry will be ignored. Hence, output is, hence result is 0, 0, 1, 3, 0, 1. Agreed? So this is what the two's complement of a number. So whether this value is correct or not, how do we verify? Anyone from us, how do we verify? So then what we have to take the decimal equivalent of this one and take the decimal equivalent of this one, perform the subtraction. Whatever the value is there, that value must be equal to this is the one. Okay. So as everybody knows that, see, this is actually a largest number. Whatever knowingly or unknowingly, what we have done is that it is a large number. It is a large number. It is a small number. Okay. So what we have done so far, large number minus a small number we have done. So we didn't find any kind of problem. That's the reason why whenever we have a large number by a small number or large number subtracted from a small number, sorry, small number is subtracted from a large number, obviously when we perform the complementation, carry come in the picture, there is no doubt. Okay, if the carry is not come, then other things will be have to think in different way, but certainly carry will be available. Just you have to ignore the carry, the remaining thing will be your answer. Agreed? Now, so second case, let us consider y minus x, let us see. Okay, so what we have done so far, so this is what we have done. Now what we would like to do, so we have to perform this one. Okay, and I want here. Okay, so what we have to do, what is this number now? What is the y value that I have taken? What is the y value? 130. Okay, 1, 4 zeros, double 1. From that 1, 0, 1, 0, 1, double 0. Okay, this is what I have to perform minus. So as everybody knows that this is a small number, this is a large number. So how do we say that that is a small number So now what is the value of here? So what is happening here now? This is 0, it becomes 1. It is 0, it becomes 1. This is 1, 1, 0, 1, 0. So this is the answer. Okay, therefore the 2's complement of this number is nothing but 0, 1, 0, 1, 1, 00. So we have to perform the subtraction based on this. Okay, 1, 0, 0, 0, 0, 1, 1. Okay, so if you add this one is 0, 1, 0, 1, 1, 0, 0, what will happen? Plus symbol. So what is this value? This is 1, 1, 1, 1, 0, 1, 1. So you observe carefully. This one. What is happening here? So this is the value. Okay, this is the value. So you observe that there is no carry here. So here observe no carry. No carry. Which signifies that we need to take 2's complement of result. 2's complement of result. This is what we have to take. Agreed? So carry legadankonde compulsory we have to take 2's complement of that number, and which means that is right. So what is the 2's complement of this result? 1, 1, 0, 1, 1, 1, 1. What is this 2's complement? 0. So 2's complement of this number is 0, 0, 1, 4 0. Plus 1 we have to add. 1, 0, 0, 0, 1, 0, 0. So this is the answer. Right. So this is what the answer for this. Therefore, this value becomes, so y minus x is equal to minus of 0, 0, 1, 0, 0, 1. So that's all. So I think this is the same as that we have got previously. Okay. Okay, if you want to perform the same operation by using 1's complement. Okay, so one question is that perform x minus y comma y minus x using 1's complement, for example. So what we have to do then? Okay, so the similar kind of thing only we have to consider. Okay, so I'm going to copy all these things for the sake of reducing the time. What is this? Okay, so here what I'm going to do, I don't want to consider this one. Okay, oh, come on. So I have to take one's complement of this number. Okay, one's complement of this number. So what is the one's complement of this number? I have to write one's complement of this number. So it's not one's complement. Okay, so no need to add one here, no need to add one here. So that is the only one thing. So one's complement of this number is simply this is the one. Okay. So that is what we have tried. So what is this one's complement? 0, 1, 1, 1, 1, 0, 0 is the this thing. Like if you add one, if you add these two things, what will get? 0, 0, 0, 1, 0, 1, 1, 1, 0, 1, 0, 1. Is normally called as end around carry. End around carry. Okay, that means this carry must be added here. Okay, where this carry is coming from? So the way this plus one is coming from, it is from this carry, right? So we have to add these two things. What we'll get? So this is the 1, 0, 0, 0. Okay, next one, 0, 0. So this is the answer. So whatever we have calculated previously, therefore 0, 0, 1, 0, 1, that the same as this one also. So even if you are opting the one's complement, we'll get the same answer. Then why we have gone for the two's complement? Okay, so one answer for this one is we have a different alternatives are there. The second reason for this is the hardware cost is less when compared to the one's complement. Two's complement is very easy to implement than that other one's complement, because we have to give another addition block. That means plus one we have to add here. Okay, so that needs some extra hardware to implement this subtraction. That's the reason why there the carry is ignored. So previously what we have seen that the carry is ignored. So general cases is that a larger number to small number only we do. So there the carry is generated, that carry is ignored. Therefore, we don't want to use any other extra hardware for that. That's the reason why we have used the, we would like to use this two's complement than that of the one's complement. Okay, so let us take another one that what if a small number to larger number. So the same arguments is applicable, but there is no carry is not available. Okay, so for example, if you want to perform y minus x, for example, so what we observe here, you notice that here carry cannot be generated. Carry cannot be generated. Please remember, carry is not generated. Hence, the result is a negative number. Okay, result is a negative number. and negative number, and take the ones complement of the result. Take the ones complement of the result. Ones complement of the result. So I'm not doing here the result. Agreed? So is there any doubt is there? I have written simple comment, I have written there. Fine. So this is all about the arithmetics related to the ones complement and the twos complement and all other things. Okay. So let us go for another concept that is called codes, binary codes. Okay. We would like to discuss about binary codes. Okay, binary codes. So why we have to use these codes? What do you mean by a code actually? The code is actually a set of bits, a group of bits. Simply we can write a code. Code is nothing but a group of bits, a group of bits. Why we need to group the bits? Okay, so actually the information is in the form of the number of bits, right? The information is a set of bits actually. Okay, so we want to, if you want to send an information from one place to another place, there is a possibility that the third party can see what you are sending, right? So if you are sending a comfortable manner by 8421 information, or maybe whatever the information, set of information, if your conventional method, if you send, okay, the third party is able easily can track what information that you are sending. But in the world of digitization, security is also one of the important consideration. Therefore, for the purpose of security, okay, we have to divide the entire message into different set of divide the entire thing in the form of a small bits, a small number of bits, okay, or a group of bits. Okay, so therefore why we have to use this one? In order to secure the code, secure the message or data. Okay, this is the purpose that we are using, right? Agreed? So these are the two reasons why we have to consider. Okay, so what do you mean by a bit? What do you mean by this one? A code is nothing but a group of bits. Why we have to do this one? In order to secure the data. Okay, that's the 2 points that we have to remember. So what are the available? So how do we make a set of bits? Okay, a group of bits as a one code. Okay, so the different possibilities are there. Okay, different methodologies are there. Methodologies are there. So one of the important methodologies is nothing but, okay, so for example, different methodology annanga ikkada adam. For example, 8421 code. This is the one, and a set of 4 bits I'm going to consider. Those bits weights are something like this. Next one is 2421 code. This is another code. Okay, next XS3 code. XS3 code. This is the one. The next one 84 minus 2 minus 1. This is the one code. Next gray code. So gray code. This is the one thing. Okay, so this is called gray code. Okay, this is called gray code. Next one also say that the Ascii code. Ascii code also. So these are the different codes that are available in our hand. Okay, so you can use any one of the coding style. Okay, you can set group the bits in any one of this code and you can send that one. So the third person is not able to identify what exactly the information is all about. Okay, so let us realize how do we mention this one. So please remember that this 8421 code is also called as BCD code. Okay, this is also called as binary coded decimal. Okay, what we can call it as binary coded decimal, BCD also. 8421 code is also called as binary coded decimal. So that means that whatever the decimal numbers are there. For example, decimal digits. Decimal digits. How many are there? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the binary codes. Sorry, the decimal codes. So how do we represent the binary code for the BCD number for this one? BCD of this number is so what is the BCD of this number? 4 digits I will have to use. Okay, so I want to represent 4 bits for this one. Okay, therefore 4 bits means 0. So what is the weight it follows? 8421 weight. It follows 8421 weight. Okay, so for example 0 I want to quote. What is the weight for the 8 position weight? 0. The quotient is must be 0. 4th position quotient is 0. 2's position is 0. 1's position is 0. For example, 1 is required. 0 0 1 is required. For example, 2 0 0 1 0 0 0 1 1. Next is 0 1 0 0. Agreed? So just by using weights, we know very well about 8421 code. Okay, so that's why I'm writing very quickly something like this: 0 1 1 1. Next 1 0 0 0 0 1 0 0 1. So that's it. So therefore, if I'm using the BCD coding, then for example 7, how do I represent? 0 1 1 1 only I would represent. For example 8, if I'm represent 1 0 0 0 0. For example 2, I am saying that it is a BCD number. Then immediately you have to think about it. It's a 0 0 1 0. That's how we have to write. Agreed? Next one is 2421. Next one is 2421. So 2421, it says the weight of this number. It says the weight of the 2421 says that weight. For example, if I want to represent 0, what I have to do? Anyone from the class? All zeros, right? All zeros. For example, 1 I need. Then 0 0 0 1. So therefore, this is 1 is required. Last bit is required. 2 is required. 2 is required. What we can do that? Anyone from the class? 2. Where I need to consider that one for 2. Students, please respond. Easy kada. So 2 means only 0 0 1 0. I can put it here. That belongs to 2. For example, 3 I need. What I can do then? 0 0 1 1. So just to find on values now, add this is we have to add these numbers. Okay. So for the required decimal value. For example, I want to have 4. 4 means, so therefore 4 means 0 1 0 0. I can write it there. Okay. 0 1 0 0 is there. 4. Next 5. 5 means
0 1 0 1.
0 1. 6 means
0 1 1 0.
0. 7 means
0 1 1 1.
0 1 1 1. 8 means 1
1 1 1 0.
So 9 means all.
1 1 1 1.
So that means, so if I say that for example I want to represent 4, sorry, for example 3 also same thing only. 8 I want to represent, for example, in 2421 code, then what is the value that you should say?
1 1 1 0.
Exactly, 1 1 1 0. That's how we have to write. So therefore the third person is not able to identify what exactly the code it is. Actually in a BCD number, we thought that this is what is the value of this one now? It's 14 actually, but it's not 14 in 2421. So that's it. Okay, so only just you have to think about it. These are all meant for hiding our information in a secure manner. Okay, that's it. Next one is XS3 code. Okay, Next one is called XS3 code. So what is this XS3 code is that whatever the decimal digits are there, just you have to add +3 to that. XS3 stands for add +3 to that number. Okay, so this is the one way that people were used in the previous computers. So they were used to represent the data in the form of the XS3 code. Okay, so in that one, if you want to have a 0, what is the XS3 code for this one is +3 we have to add for that. Okay, that means so this is 0 0 1 1. Agreed? So therefore what I have done, just it is 0 plus 3 I have added, that means 3 only. What is the 3 value of this one? 0 0 1 1. So next one is this one. So what is this XS3 code for this one is 1 plus 3, that is 4. 4 means
0 1 0 0.
0 0. So that's it. So 0 1 0 0. 2 means 5 0 1
0 1.
0 1. 6 0 1 1 0. 7 0 1 1 1. 8. Next 1 0 0 0 0. 9. Okay, what is the next one, Babu? It is 6 plus 3 9 1 0
1 0 0 1.
7 plus 3 10 1
1
0
0 1 0.
30 8 plus 3
1 1 0 0.
1 1 0 0. Okay, 9
1 1 0 1.
Okay, very good, thank you. So this is how. So our intention is that I want to mention only the decimal digits, not other things. Okay, so how many other unused states are there here? Anyone guess how many unused states? For example, if you're using the 4 digits order and any possibilities of same, how many possibilities are there? As we mentioned that 2 power n, so 2 power 4 bits, that means how many are there? 16 possible combinations has to come from 00 to 16, but only 9 వరకే వచ్చినాయి. So మిగతా అన్ని కూడా unused state అవుతాయి అన్నమాట. ఓకేనా? So that's what you have to remember. Okay, anyway, we'll talk about that information later on. For the sake of if I say that, for example, 6 in XS3 అన్నాను అనుకోండి. So what is this value that you should mention? 6 in XS3?
1 0
Yeah,
0 1.
6 plus 3 అంటే 9 మెన్షన్ చేస్తే సరిపోతుంది. 1 0 0 1 మెన్షన్ చేస్తే సరిపోతుంది. That means this is the one only. Okay, 6. Right? Next 8 4 2 1. Next one is 8 4 minus 2 minus 1. So negative numbers also we are writing. Okay, so that means that I'm giving the weight, means 8 into whatever the bit position plus this weight into that bit position minus 2 into that bit position minus 1 into that bit position. That is what the meaning of this one. Okay, 8 4 2 1. So for example, if I write 0, I want to mention in 8 4 minus 2 minus 1, then what is this value? All are zeros only. There is no difference in it, because now I would like to define 1 in this particular code. So what is the value then? What is this value? 1 కావాలంటే ఏం చేయాలి బాబు మనం?
0 1 1 1 sir.
Yeah, 0 1
1 1
1. So అప్పుడే మనకి ఇది 0 వచ్చింది. Next this is
4 minus 3 1.
Exactly. So therefore the 4 minus 3, that is equal to 1. Right? Alright, next 2.
0 1 1 0.
0 1 1 0. Like this we can write some 9 ఎట్లా రాస్తారు? 9 9
1 1 1 1.
1 1 1 1.
1 1 1 1. So if you add all those things, it becomes 9 only. Okay, 12 8 plus 4 12, 12 minus 3 9. Okay, so we can please all of you please try to fill this form. Okay, next very important one is gray code. Okay, so the next one is gray code. So the gray code is actually having a specific meaning for this one. So very important uses are there. So actually in this one, from previous combination to the next combination follows only 1 bit variation. So I will tell you that point now. So now how do we get this gray code now? Okay, So gray code, how do we get it? So something like this. For example, 0001 I'm writing. So what is the XS3 code for this? If I'm asking, what you have to do, we have to take the MSB bit is as usual. So I can consider 0. Okay. But if you want to get the next one, I have to perform the exclusive OR operation between these two. Okay, what is the XOR operation between these two? We should know about it. What do you mean by XOR operation? XOR operation. So far we have not done, right? So XOR operation means this is the symbol that we normally use. Okay. And for example, 2 bits are something like this, another 2 bits are, another 2 bits are, another 2 bits are there, right? For example, AB I'm writing here. If the 2 bits are same, then we'll produce the output is 0. If 2 bits are same, output is 0. If the 2 bits are different, output is 1. Output is 1, right? So this is what the XOR operation will perform. Okay, see, we will see the different operations later point of time. Just you have to remember in this way. So if the 2 bits are equal, then for what is the output here now? This value is equal to 0. Similarly, I have to perform the XOR operation between these two also. What is this value? 0. So like this, we have to add here. That is also 0. That means what is the gray code for 0, 0? For 0, all zeros. For example, 1. For example, 1 is, how do I represent 1? Something like this, I can represent 1. What is the gray code for this number? And that means 1, I have, what is the gray code for 1 and unknown? Then you have to take the binary equivalent of that one we have to consider. Okay, now bit by bit exclusive OR operation we have to perform. Here, what is this value? 0 only. So from here to here exclusion operation 0 only. From here to here exclusion operation 1 becomes. So there is no change here also 0 0 0 1. For example, 2 I want to represent in gray code. So what is the 2 binary equivalent of this one? 1 0. Then can you tell me what is this value? 0
0 1 1
no.
1.
So see here, from here to here also we have to consider for the second bit 0 only. So what about here?
1
1. From what about here?
1.
1. Exactly. So therefore this is 0 0 1 1. So you can see here very carefully, from this combination to this combination, only which bit position is changed here. Only this bit position is changed. Okay, only one bit position is changed. This one bit position changing is very, very important while we are realizing the hardwares. Okay, so number of the number of components in the hardware will reduces. So this point also we will talk about a little bit later. Okay, while we are realizing the circuits. Okay, now what about 2? For example, what about 7? I want to write it 7. 7 ultra 7. 7 is equal to 0 1 1 ga rasam.
Yes,
What
sir.
gray code em rasam? Gray code em vastundi?
0
Yeah, 0
1
1
0 0.
0 0 exactly. So MSB malli MSB to next one. What is happening? Both are different, therefore 1. So then 1 to 1 0 1 to 1 0. Okay, therefore the 7 requires 0 1 0 0. For example, 8 this one. For example, 8. For example, 8. 8 and rasa 1 0 0 kada rasedi. What about 8 gray code em 1 1 0 0. Therefore, what I can write now? 1 1 0. So where we can find the change here now? This one. So please remember that I have written just wrongly. It is for the 7. Okay, my point is you can understand. Okay, that is the 7. That is 8. Okay, please all of you fill this all these things. Okay, please do not neglect. So this is for the 7. This is for the 8 related Greek code. Is it clear to all of you? Now, another important one is Ascii code. Okay, so sometimes it is not possible to represent a particular data in the form of numbers only. Okay, decimal numbers only, 0 1 2 3 4 5 is not sufficient. Then we have to use alphanumeric codes. Okay, what we have to do is sometimes we need to have alphanumeric codes. Okay, so alpha numerics. Okay, this is called alphanumeric code antam manam. Endante for example 732ABC for example or x ananu. Okay, so this is one number actually. Okay, instead of saying only the numbers only 5 6 7 2 4 0 something like the numbers only, it is not necessary to represent any quantity in the form of numbers. It is also possible with the help of mixed possibilities. 7 delta 3 2 5 n also I can write it. So some symbols also I can use it there, right? So therefore, if you want to mention a data, if you want to mention a data or maybe a something, it is not necessary to use the only the numbers. It is also possible the mixing of it is a mixing of, yeah, just wait. Yeah, it is a mixing of both alphabets, small letters and capital letters, and characters also. Delta is one character, special characters. I can also use it there. Okay, such type of codes are nothing but for information interchange. Okay, American Standard Code for information interchange. Okay, so according to this one, we have 128 characters we can use. Characters, 128 characters. So the simple example for this one is keyboard. Keyboard. Okay, so keyboard you have seen in your computer. So there you can see the uppercase letters, small case letters. Of course, shift you have to use, uppercase letters will come into the picture, and the characters will be there, and the different things will be there, right? So all these things are 128 characters are there. So if you want to give one particular binary information to a particular character, for example, I want to write it A, for example. Of course, we know very well about it. How many are there here? Here we have 128 are there. So now the question is that how many number of bits are there to give one particular binary information to one particular character? ఇంతవరకు ఏం చేశాను అంటే, ఫర్ ఎగ్జాంపుల్ 5 బిట్స్ అని ఇచ్చాను. సో ఎన్ని యూనిక్ కాంబినేషన్స్ నేను ఫిల్ చేయగలను? హౌ మెనీ యూనిక్ కాంబినేషన్స్? దట్ ఈస్ డిసైడెడ్ బై 2 power n. అంతే కదా? దట్ మీన్స్ 2 power 5. దట్ మీన్స్ హౌ మెనీ ఆర్ దేర్? దట్ ఈస్ 32 combinations, unique combinations నేను ఫిల్ చేయగలను. దట్ మీన్స్ స్టార్టింగ్ ఫ్రమ్ 00002 to, okay, so 111. So it can say 1111. So how many are there these things? If I say that ఏదో ఒక 5 bits నన్ను ఎన్ని కాంబినేషన్స్ వస్తాయంటే, this is how we have to mention. Okay, total of 32. Okay, like this, for example, నాకు 128 కావాలంటే రివర్స్ అడుగుతున్నాను నేను ఇప్పుడు. So what is this n value? What is this n value? చెప్పాలా?
3.
3 ఎట్లా అయింది మెషర్? 3 అంటే 8 కదా వచ్చేది, బట్ 128 కావాలి నాకు.
2 power 7, sir.
Exactly, 2 power 7. So therefore, for example, 5 అనగానే నాకు ఎన్ని వచ్చినాయి? 32 వచ్చినాయి. Okay, 1 2 3 4 5 6 7. 2 2s are 4, 4 2s are 8, 8 2s are 16, 32, 32 2s are
64,
2s are 120.
128.
Therefore, so if you want to define ASCII characters, what is the number of, how many number of bits that we have to use? The number of bits that are required is 7. So what does it ki 7 bits UCL, right? 0 0 0 0 4 0 0 1. Oh, sorry, it's not like this. Why it becomes 1, right? It becomes 1 0. Okay, 1 0. Is it right to everyone? So that means whatever the number, whatever the digit it is, for example, delta I'm writing, for example, percentage I'm writing, for example, delete and symbol ఉంటుంది, for example, capital A ఉంది, small a ఉంది, okay, something else. For each and everything, what I have to write? So what I have to write? It's 7-bit equivalent I have to write. So for the sake of completeness, I'll do one thing. I'll copy this information and I'll paste it here for your reference. Okay. So what is the binary equivalent of this one? Please let me know here. Let us know here. So please wait for 2 minutes, sir. Just 2 minutes. I'll complete it. Snipping tool open. New. Okay. Copy and then paste here. Better I will write it here. చూడండి బాబు ఇక్కడ ఒకసారి these are the 8 bits that I'm using here. So what they have done, they want to mention all these 128 in this tabular form. So here you have to remember that B7 is the topest MSB bit, B6, B5, B4, B2, B3, B1. So where these things are available? So these things are available here. Okay, so they want to accommodate all these 128 characters in the in this particular list. Okay, that's the reason. That is the motto, nothing else in it. Okay, these are these things. Okay, for example, equality. What is the ASCII code for equality? Anyone from the class? Can you guess? So this point is important for us. Okay, so therefore LSB bits are this one. MSB bit this one out. So therefore 0 1 1 and this is 1 1 0 1. Agreed? Therefore 7 bits are represented in this way for the equality. Suppose left bracket is there. So left bracket is there. So the moment if you are pressing the left bracket, the square bracket, left square bracket, for example, sorry, right square bracket, its binary equivalent will be generated, and the manipulation will be done according to that binary information. Okay, so these are the different ways that we can represent alphanumeric codes by using the binary. So all these things we can call it as binary codes. Okay, in the next class, what we will see is that how do you perform the binary code arithmetics? Okay, especially we would like to discuss about the BCD addition. Access3 addition is required. That arithmetics only we will look at in the next class. Okay, so with this we have completed the binary codes. Okay, so up to this point you'll have an examination. Please go through it once again. Okay, so as soon as possible I'm going to post this video, the audio lecture, sorry, this notes in your Moodles. You can take it from the Moodles. Okay, all the best for your exam. Don't hurry and don't get panic. Please go calmly and coolly. You have tried the exam. Okay, don't worry about it. Is there any doubt is there regarding whatever I have we have discussed previously? Anyone from the class, if you have any doubt, please let me know.